Hello friends, welcome to Risingpearl.com. I'm your friend, your host Roy. This is series 2 where we are discussing triangles. Friends, today is webisode number 4. Today we are going to continue our discussion on what are similar triangles. We are learning more about the concepts of similar triangles. In the last video we saw that if I have two triangles ABC and triangle PQR, and if I say that these two triangles are similar, and you saw we represent the similar symbol by this kind of a symbol, right? Similar triangles, what it really means is that the corresponding angles must be equal. So in this case, angle A and angle P should be equal, angle B and angle Q should be equal, and angle C and angle R should be equal. That is, these values must be equal. That is our first condition. So let us write it down here. Angle A must be equal to angle P, angle B must be equal to angle Q, angle C must be equal to angle R. If it is given that this triangle and this triangle are actually similar, what it means is these things must be true. In addition to that, all corresponding sides must be in the same ratio. This is our second condition. What does this mean? We saw in the last video. So the side opposite to angle A is BC. So BC divided by, because we are looking at the ratio. So angle A and angle P are equal. So opposite to angle P is which side? QR. So BC by QR should be equal to AC by PR, AC by PR, which should be equal to AB by PQ. It doesn't matter, friends, if you write it like AC by QR or QR by BC, right? But the idea is that if you actually measure these lengths, these ratios, that is BC to QR, AB to PQ and AC to PR, each of these ratios must be equal. Now let us understand that how does it look in practice. So I want to finally draw two similar triangles. Okay, so let us see how we can actually start. So I have a triangle ABC. I have drawn a triangle ABC, and let us assume that, for the example purposes, that in triangle ABC I have drawn it in such a way that the measure of BC is 9 centimeter, AB is 3 centimeter, and AC is 6 centimeter. I have just drawn a triangle like this, and I have also measured this angle. This angle is 30 degrees. So what I do is I want to draw a similar triangle which is 2 times the size of this triangle. That is what I want to do. So how do I go about it? So first of all, so I'm going to draw a triangle here, and my triangle will be PQR eventually. So what I have is my BC to QR will be, I want to draw 2 times the size of this triangle, right? And BC is 9 centimeter. So I want to draw something which is 2 times 9 centimeter, right? So my ratio will be 1 by 2, right? That means I want to draw this 18 centimeter. So I draw a line QR. So BC is a horizontal line. So I draw a horizontal line QR, and I draw it so that it measures 18 centimeter. Okay. Then what do? Then I actually I look at angle B, which is 30 degrees, right? Angle B is 30 degrees. So at point Q, on the line segment QR, at point Q, I draw a line which is 30 degrees. I want to make sure these two angles are equal, and I draw a straight line. Then what do is that on this line, remember again that because I'm trying to draw a similar triangle, and this side AB is 3 centimeter. So here PQ should be 6 centimeter, right? Because each of the ratio, if this is 9, this is 18. If this is 3, this should be 6, right? Because the ratio has to be the same. I cannot have this as the double and this has 3 centimeter or 5 times 15 centimeter. Because remember, in order for me to draw similar triangles, these ratios must be the same. So BC is to QR is 1 by 2. Similarly, AB is to PQ should be 1 by 2. So if this is 3, this should be 6. So on this line that I have drawn the 30-degree angle, I measure with a ruler 6 centimeter, and I find my point P. And then simply I join PR. I just join PR. So at this point, friends, what you will notice is that if you measure PR, you will notice that this length is actually 12 centimeter. Even though you didn't draw this to be 12 centimeter, you measured QR, you measured PQ, and you measured this angle. Automatically when you draw PR, you will notice that it is 12 centimeter. And so indeed our ratios AB by PQ is also 1 by 2, because we know that. And when we measured AC by PR, we notice that that is also 1 by 2. Not only that, if you actually measure these two angles, the value of these two angles, you will notice that they are same. You will notice that angle A is indeed equal to angle P, and also if you measure this angle, you will notice that angle C is equal to angle R. That is, the value of angle C will be equal to value of angle R. So similarly, friends, if in this case I have drawn a small triangle XYZ, XYZ, where what I did was I actually drew each to be 1/3 this triangle. So I started off with this line and I drew this line with a measurement of 3 centimeter. And then again I drew a 30-degree angle here, and again this length I took 1 centimeter. Then automatically when I measure this comes out to be 2 centimeter. So what is remarkable here, friends, is that this is how you draw similar triangles. And another very interesting fact is, if triangle ABC is similar to triangle PQR and ABC is similar to this triangle, then the small triangle is also similar to this big triangle. Because if you look at it, this is 30 degree, this is 30 degree. Whatever is the value of angle X, that will be the same as angle P, and this angle will be same as angle R. And not only that, if you look at XY divided by PQ, what is the ratio? The ratio is XY is 1 and PQ is 6, right? What about this one? XZ or XZ divided by PR, what is the ratio? So this is 2 and this is 12, which is nothing but 1 by 6. And similarly, this is 3 QR, right, equal to 3 by 18, which is again nothing but 1 by 6. So friends, these are some interesting fun facts about similar triangles, and we are just going to summarize it here by saying if triangle ABC is similar to triangle PQR, right, and if triangle PQR is similar to some other triangle, let's say DEF, then it follows that ABC, the first triangle, is actually similar to the third triangle DEF. Now friends, one other important point to note here is that this idea that in two similar triangles corresponding angles are equal and corresponding sides have same ratio, it is not only true for triangles, but it is true for polygons in general. So when do we say two polygons are similar? So in any two polygons with same number of sides, if all corresponding angles are equal and all corresponding sides are in the same ratio, we say that two polygons are similar. And also, if it is given the opposite way, that is, if we are given two polygons with same number of sides and it is given they are similar, it automatically follows that they must have corresponding angles equal and also the corresponding sides must be in the same ratio. So friends, as you recall, triangle is nothing but a polygon with three sides. So these two conditions are always going to be true for similar polygons or similar triangles or similar quadrilaterals or similar pentagons or similar hexagons. So this is very important to understand. So for example, if we were to just take a look at here I have drawn two quadrilaterals and let's just name them. So let's call this A, B, C, D. So I have a quadrilateral ABCD and let us name this as P, Q, R, S. So what it means is that angle A, if these two are similar, they look like exactly same shape, bigger size. That means angle A will be equal to angle P. It means that angle B will be equal to angle Q. Angle C will be equal to angle R. And angle D will be equal to angle S. So this is about the first condition, that all corresponding angles must be equal. But also we know that their corresponding sides must be in the same ratio, right? So it follows that, let's write it here, AB by PQ, this ratio must be equal to BC by QR. It must be equal to CD by PS, CD by SR or RS, which must be equal to AD by PS. So this is the second condition which states that each of these sides, so not only I have these angles being equal, are equal, in addition to that, my corresponding sides, that is this side to this side, that ratio must be identical to this divided by this, identical to this divided by this, and AD divided by PS.